Hi everybody, welcome to part 2 of 1.6 extension video, adding and subtracting fraction. In the first video, I gave you this example at the end of the video, and I asked you to solve. So now here's the answer to solve that, okay? 8 and 6. I need to get a common denominator of 8 and 6. So I'm going to use hockey stick, kind of off to the side, okay? 2 is a factor that can go into both numbers. So I'm going to put 2 here. And then 2 can go into 8 4 times. 2 can go into 6 3 times. Okay? 4 and 3, they do not share any common factors besides 1. So I stop. GCF is on the left, but LCM is all of them. And then as you notice, that it kind of looks like an L. Okay? And I need to multiply. 2 times 4 times 3. That is 24. So I need to change 8 to 24. In order to change 8 to 24, I have to multiply by 3, okay? 8 times 3 is 24. Whatever I do to the bottom, I do it to the top. So what's 5 times 3? And the answer is 15. So this is 15. 15 over 24, okay? Plus, now 6, I can change this to 24 as well. In order to change 6 to 24, I multiply by 4. Whatever I do to the bottom, I do it to the top, okay? So now 1/6 is no longer 1/6, but 4 over 24. Now I add the numerators. 15 plus 4 is 19, and keep the denominators the same. Since I can't simplify anymore, this is my simplest form. That's my final answer. Okay. Same thing with 6 and 9. Okay. 6 and 9, let's find the lowest common denominator. The factor that they both share is 3. 3 can go into 6 2 times. 3 can go into 9 3 times. And that's it. I can't keep going. So GCF is on the left, but LCM is all of them. 3 times 2 times 3, that gives me 18. Okay, so 18 is the lowest common denominator. So I need to change this to 18. In order to change 6 to 18, times 3 top and bottom. In order to change 9 to 18, I multiply by 2, so I need to multiply by 2 here, so that's 10. And now I add the numerators and keep the denominators the same. So 3 plus 10 is 13, and I can't simplify anymore, so that is my answer. Okay. Now, same thing with subtraction. Subtraction is the same exact process, okay, except now instead of addition, it's subtraction. But let's talk about mixed numbers. Okay, and we did an example of this in our DOM recently. Add and subtract mixed numbers. And the process is very similar, okay? There's actually 2 ways to solve this. 2 ways. So what I want us to solve is 5 and 2/3, take away 2 and 1/4, okay? Let's do way number 1. So step 1 is write the difference using improper fraction, okay? If you're not familiar with improper fraction, I'm going to quickly, briefly talk about it, but if you need help, come and see me. Improper fractions, okay? So I'm going to rewrite 5 and 2/3. How I do that is basically the denominator multiplied the whole number, okay? I multiply, and then I add that to the numerators. So 3 times 5 plus 2, okay? 2 and 1/4, same thing. Denominator multiplied by the whole number, and I add that to the numerator. So it'll be 4 times 2 plus 1, okay? 3 times 5 is 15. 15 plus 2 is 17. So it's 17 over 3. 5 and 2/3 is 17 over 3. Minus 4 times 2 is 8. 8 plus 1 is 9. So 2 and 1/4 is the same thing as 9 over 4. Okay, I rewrote the fraction. Step 2. Find LCD. Lowest common denominators. Okay. 3 and 4, the lowest common denominator. We did one similar to another problem. 3 and 4, since they don't share a common factor, I just multiplied 3 and 4, okay? Because if I keep doing hockey stick, the only thing I can put is 1, okay? And it's going to be 1 times 3 times 4 anyway. So 1 times 3 times 4 is 12. So 12 is the LCD. Step 3. Rewrite fraction with LCD. Okay, so 17 over 3 minus 9 over 4, I want to change 3 to 12. So in order to do that, I need to multiply 3 times 4 to 12, so that means 17 times 4, okay? You don't have to do this in your head, okay? Write this off to the side. The answer is 68. And I get to change 4 to 12. In order to do that, I multiply by 3, so I need to multiply the top by 3 as well, so that's 9 times 3 is 27, okay? 68 minus 27, okay? Step 4. Subtract numerators. Oops, I think I shift it up. Keep denominators the same. Okay? So 68 over 12 minus 27 over 12. 68 minus 27 is 41 over 12. I'm running out of space here. Okay? Let me kind of flip to another page. So, step 5. There's a step 5. Simplify. If needed. Simplify also sometimes means change improper fraction back to mixed numbers, okay? If it doesn't specify, you can actually keep this as 41 over 12 as long as simplified, okay? But since 41 over 12, I'm going to show you how to change this back to mixed numbers. It's kind of the opposite of what we did for changing it to improper, okay? But 12 can go into 41, so I'm going to rewrite this. It's a division problem, basically, okay? 12 cannot go into 4, but 12 can go into 41 3 times. 3 times 12 is 36. Take that away, and then that's the remainder, okay? So let's rewrite this. 3 is my whole number. 5 is my remainder, and 12 is the denominator for all the other columns, where 12 is also the divisor. Okay, and that's my final answer. So this is the number of times 12 goes into 41. Okay, 12 can go into 41 3 times. This numerator is my remainder. And denominator should stay the same, or it's also the divisor. Okay? So that's pretty much how to add and subtract mixed numbers. We did an example with subtraction. Now we can do one with addition, okay? But that was way number 1. I'm going to show you another way in my 3rd video. So stay tuned for that, and I'll see you later. Bye.